In this video, I'm going to walk through two examples of how to find the inverse of a 2 by 2 matrix. So the very first thing is that we are going to append our matrix with the identity matrix. And then our goal is to make the left side of this matrix look like my identity matrix. Alright, so we're going to try and make this left side look like this right side right here, using our matrix operations that we know, that we learned back in Chapter 4 when we were solving systems of equations using matrices. Okay, so I'm going to draw my diagonal as always, and I have two numbers this time. If I want the left side to look like my my identity matrix, I need to make a 0 here and get a 0 here. Then I can worry about getting ones along my diagonal. So the first thing I'm going to do is I'm going to take a look at the number on the diagonal and see how I'm going to use these two numbers to eliminate the 6 on the bottom. So I think what I'll need to do is I will need to multiply my first row by a -3 and add it to my second row. So now we're not changing the first row, we're going to keep it the same. So I'm going to multiply my first row by -3, so I get -6 plus 6 is 0. -15 plus 1 is a -14. -3 and 0 is a -3. And 0 and 1 is 1. So the next thing I'm going to do is draw my diagonal. I have my 0 in place in my first column. I need to get my 0 in place in my second column. Oops, I should have drawn this in with a black pen. Okay, so I'm going to circle the number on my diagonal again. We're working on column 2. I'm going to take a look how I can use the 14 and the 5 to eliminate the 5. So I think what I'm going to do is I'm going to multiply my first row by a 14. And I'm going to add to it 5 times my second row. And when I do that, I get 28. I get a 0, I get 14 plus a -15 is a -1, I get 0 plus 5 is 5, and then if I copy my second row, it looks like we're good with our zeros. We have zeros in the places that we want them. Now that we have our zeros, we are going to divide both rows so that we end up with 1s along our diagonals. So I'm going to take my first row and divide it by 28, row 1 divided by 28. I'm going to take my second row and I'm going to divide it by a -14. And when I'm done, I get a 1, a 0, a -1 over 28, and a 5 over 28. Then I get a 0, a 1, a 3/14, and a -1/14. So this right here is going to be my inverse matrix. So now that I'm done, the right hand side is my inverse matrix. So how do I check to make sure that I have the right answer? I'm going to take my original matrix, and I should be multiplying my original matrix both ways with my inverse matrix on the left and then again with it on the right. But in this case, I am just going to, for time's sake, I'm just going to test one way just to make sure I am correct. So I'm going to multiply this first row by this first column. So I get a -2 over 28 plus 15 over 14. Now when I move down to my second row and do my multiply, I get a -6 over 28 plus 3/14. Now I'm going to go ahead and move to my next column and the first row. And so I'm going to multiply these, so I get a 10 over 25 minus 5, oh sorry, that's a 28. And I have that as a mistake in multiple places. Minus 5 over 14. And then I'm going to move down and multiply my second row. And I get a 30 over 28 minus 1 over 14. So let's go ahead and simplify that. This becomes a negative 1/14 plus 15/14 is 14 over 14, which is 1. This becomes a negative 3/14 plus 3/14 is 0. This becomes a 5/14 plus negative 5/14 is 0. And this becomes 15/14 minus 1/14 is 14 over 14, which is 1. So that checks out. Okay, so I'm going to do one more example because I want to show you an example of a special case here. I'm going to find the inverse of the matrix let's see. I will do 4, 2, 2, 1. So find the inverse of this matrix. Okay, again, I'm going to draw my diagonal, circle the number on my diagonal, and ask myself, how am I going to use these two numbers to eliminate the 2 underneath? What I'm going to do is I am going to multiply row 2 by a negative 2 and add it to row 1. And when I do that, I get negative 4 plus 4 is 0, negative 2 plus 2 is 0. I get a 0 plus 1 is 1, and a negative 2 plus 0 is negative 2. Okay, so I want you to notice something here. I have this row of zeros on the left-hand side. No matter what I do, I can't get a 1 here, I can't get a 1 in that position, and a 0 in this position. If you ever run across the case where you have you get a 0 in one of these rows on the left-hand side, you have what is called a singular matrix. This original matrix, 4, 2, 2, 1, is called a singular matrix because no inverse exists. This is important because when we start solving systems of equations using matrix equations, you're going to need to check for this. This is considered a singular matrix. No inverse exists for this matrix.